All right, welcome back. Continuing looking at differentials and linear approximations. In the previous video, we talked about how dy might be a lot easier to calculate than delta y. And I'd like to look at an example of that. In fact, I've got three examples for us today. And the first one I want to look at is dy and delta y. All right, so given a function, f of x equals x squared plus 3x. We'll make it nice and well-behaved, nice and easy. At x equals 2, with my delta x, which we know is the same thing as dx, 0.1. And what I want to do is I want to calculate dy and delta y. All right, here we go. So first, I know I'm going to need the derivative of this function here. I don't know the y value there, do I? I'm going to need to do that at some point. So let's see. F of x equals... I was doing the derivative already, wasn't I? X squared plus 3x. So the derivative is 2x plus 3. At x equals 2, the derivative at 2 is 2 times 2 plus 3. 4 plus 3 is 7. Therefore, dy is, remember, the derivative times delta x. So dy is the value of the derivative at x, which is 7, times the differential dx, which is 0.1. So dy is 0.7. All right, so now let's compare this with a calculation of delta y. All right, so delta y. Now, when x is equal to 2, what's the value of the function? Y equals f of 2, which equals 2 squared plus 3 times 2, 4 plus 6, 10. So when x is 2, the value of the function is 10. The x value is going to be 2 plus delta x, which is 2 plus 0.1, 2.1. So y is the value of the function at 2.1. What's the value of the function at 2.1? All right, so that's going to be 2.1 squared plus 3 times 2.1. And on the calculator, if I work that out, I'm running out of the bottom of the page here, aren't I? If I work this out on the calculator, it's going to be 10.7. So delta y, I'm ready for my delta y calculation now. So delta y is going to equal f of 2.1 minus f of 2, which is going to be 10.71 minus 10, which is 0.71. That's my delta y. And what was the dy? The dy was 0.7. So 0.7, my dy, remember, dy is approximately delta y. My dy was actually 0.7, which is approximately 0.71. Notice how the delta y calculation was a lot more involved. We had to do a lot more things to get the delta y calculation. But they're approximately the same. They're about the same. So it's close enough. And certainly the dy calculation is a lot easier. All right, let's take a look at a sample problem. I've got two sample problems for us. The first one involves a circle with a radius of 20 centimeters. Now, the radius has a possible error. So the radius is 20 centimeters with a possible error of 0.02 centimeters. So we're going to use differentials to estimate. We're going to use the differentials to estimate the maximum error and the relative error for calculating the area of this circle. So use differentials to estimate the maximum error and the relative error for the calculation of the area of the circles. So use differentials to estimate the maximum error and the relative error for the calculating the area of this circle. All right, so here, let's take a closer look at this. So here's my circle, and the radius is 20 centimeters, but with a possible error. The radius could be a little bit bigger or a little bit smaller. The possible error here is the 0.02. Now, what does that represent in my differentials? The 0.02, that's going to be my delta x or my dx. This is my delta x or my dx. Remember, they're the same. Go back and look at the graph that we talked about earlier, and you'll see that they're the same. All right, calculating the area of a circle. Area equals pi r squared. Take the derivative of this, and I'm going to use differentials here. So when I take the derivative, I'm going to have dA equals, pi is a constant, pull that out, pi times 2r dr. If I simplify this up here a little bit, dA equals 2 pi r dr. And I know what the radius is, and I know my possible error here. Substituting in the error of the calculating the circle is going to be 2 times pi times 20 times 0.02. My dA is going to be, let's see, 20, 40, 0.2, 0.08 pi, 0.08 pi, whatever that is. And that's going to be my maximum error. So there's my maximum error. It's going to be 0.08 pi is my maximum error. What's the relative error? Well, the relative error, so here's the max error. The calculation for the relative error is going to be maximum error over area. So 0.08 pi over pi r squared. And put this on the calculator, and we're going to get 0.002. Notice that my units are going to cancel here. This is a relative error of 0.2%. There's my relative error in calculating the area of this circle. All right, one more example. And what I'd like to do for this example is I want to give you a sample problem that could be used on a test, on a multiple choice test, or on the AP test. This is definitely going to be a calculator type of question, unless we leave our answers in exact form, as you saw back there with pi's and so forth. But let's take a look at a sample question. Here we go. So, if differentials are used for computation, then the best approximation in cubic inches and here comes the situation. So if in this case, if differentials are used for computation, then the best approximation in cubic inches to the increase in volume of a sphere when the radius is increased from 3 to 3.1 inches is what? So the to the increase in the volume of a sphere, when the radius is increased from 3 inches to 3.1 inches, what would it be? And let me give you 5 possible answers here. A, B, C, D, and E. So for A, I'm going to say 11.3. B, 11.7. C, 12.1. D, 33.9. And for E, 39.7. All right, so let me pause for a moment, read this, and talk about the problem here. So in this problem, if differentials are used for computation, then the best approximation in cubic inches to the increase in the volume of a sphere when the radius is increased from 3 to 3.1 inches is what? And we have to pick one of these answers here. All right, so volume of a sphere, that's going to give me my direction. That's going to tell me what I'm going to need. So volume of a sphere is 4/3 pi r cubed. Take the derivative of this with differentials. I'm going to have dv equals 4/3 pi times 3r squared dr. Now I know what the radius is, and I know the change in the radius. Substituting in here, dv is 4/3 pi times 3. Those 3's are going to cancel. The radius here is at 3, and the dr is 0.1. And look at these answers here. They're certainly decimals. I'm going to have to plug this into the calculator. The 3's cancel. 12 pi, 1.2 pi. Oh, I forgot the r squared here, didn't I? Oh, be careful. R squared, that's an r squared. So the 3's cancel. 4 pi, 9, 36 pi, 3.6 pi. And when I multiply it all out on the calculator, I'm getting 11.3-ish, and here it is. There's my answer, 11.3. That's the best answer. All right, so there we have differentials and approximations, using differentials for approximations. Tomorrow, ladies and gentlemen, tomorrow we will be reviewing, and then we will have the test. Review for the test. Try to get all your homework done. Get everything done and turned in by tomorrow. And then during the review, I do have an in-class activity for you during the review. I might be able to Skype in. I don't know at this point. We'll have to see. But we're still going to keep going forward here. So tomorrow on Wednesday, we will be doing the review activity. And then Thursday and Friday will be the test. Thursday, AP style will be multiple choice without a calculator, and then multiple choice with a calculator. And then on Friday, again, AP style, we will have short response with a calculator. And then at some point, the calculators get taken away, and you will have short response without a calculator for the rest of the test. All right, well, I miss you guys. I wish I was there in class with you. I'm sure you're doing well. I know that these videos, they're not the best of videos, and I apologize. I'm not really a video star. Don't want to be, don't intend to be. I want to be in front of the classroom. That's where I really want to be. So I'm looking forward to coming back to class as soon as possible. And by the way, how about those Chiefs? I just got done watching the Super Bowl. Chiefs won. That was a really good game. I really enjoyed that game. So I look forward to seeing you guys again real soon. Bye-bye now.